Hello guys, this is a video solution for your physics worksheet. Okay, let's start with question 1. Figure 6.1 represents waveform of a sound wave. The wave is traveling at constant speed. On figure 6.1, label with letter X the marked distance corresponding to amplitude of the wave. Now let's have a look where is the amplitude, right? So first, to understand amplitude, what you should do is you should draw a mean position. Only then you can find out what is the amplitude. Amplitude is the maximum displacement from mean position. So this should have been marked as letter X, right? You should mark this as letter X in your answer. The label, to label the letter Y, mark distance corresponding to wavelength of the wave. So wavelength should be from one crest to crest, from trough to trough, or from one mean position, and it should travel to the second mean position. So this should be your wavelength. State what happens to amplitude when wavelength of the wave and wavelength of the wave if loudness of the sound is increased with constant pitch. Frequency is pitch, so if frequency does not change, wavelength also does not change, right? And if loudness increases, amplitude increases. The pitch of the sound is increased at constant loudness, so the amplitude remains same, so I'll write no change, right? And wavelength, if pitch increases, right, we know that V is equal to F lambda, and frequency is pitch. So if pitch increases, frequency has increased, and for the same wave the wavelength has to decrease, so I will write decreases. Then we have a ship uses pulses of sound to measure the depth of seabed beneath the ship. A sound pulse is transmitted into the sea and echo from the seabed is received 54 milliseconds after. The speed of the sound in seawater is 1500. Calculate the depth of the sea beneath the ship. You should remember the speed of sound. They don't tell you to in your syllabus or anywhere, but it will be beneficial for your further questions if you do remember this. Now we know that speed is equal to distance upon time, but the sound goes from the ship, right? If this is the ship, it goes to the seabed and then comes back, so it has traveled twice the distance. So 1500 is equal to 2d. It has traveled 2 distance, and all of this is done in 54 millisecond. Milli is 10 to the power minus 3, right? To solve this question, what would you do? You would make d the subject of formula. So d is equal to 1500 multiplied by 54 multiplied by 10 to the power minus 3, and the whole thing divided by 2. If you do that in your calculator, you will find that the answer is 40.5. Units are not specified, so you are supposed to write the units as meter, because speed is in meters per second, the depth will be in meter. Explain what is meant by total internal reflection. Bouncing back of wave into denser medium. Then what is critical angle? The angle at which ray has refracted angle of 90 degree. Then figure shows a ray of light traveling in air incident on the glass prism. The speed of light in air is 3 into 10 to the power 8. Its speed in glass is 2 into 10 to the power 8. Calculate the refractive index of the glass. We know refractive index is speed of light in vacuum or air divided by the speed of light in that medium. So n is equal to 3 into 10 to the power 8 divided by 2 into 10 to the power 8. This will give you 1.5. As refractive index is a ratio of two similar or same things, meters per second and meters per second, therefore refractive index itself has no units. Then show that the critical angle of glass air boundary is 42. We also know that n is equal to 1 by sine c. So I can write sine c is equal to 1 by n. So I can write out sine is equal to, I can write out c is equal to sine inverse of 1 by n, and therefore c is equal to sine inverse of 1 upon 1.5. Right? A lot of times a lot of kids forget to make c properly the subject of formula and get a math error. Here this is 41.8, which is almost equal to 42 degree. On figure 7.1, draw carefully without calculation the continuation of the ray through the prism and into the air. Let's find out. So here, because the angle of incidence is 90, the angle of refraction should also be 90. Once that is achieved, you can easily find out that this is also 30. So the angle of incidence, let me show you the angle of incidence. This is the angle of incidence is 60, because we have just found out that 42 is the critical angle. Therefore at 60 degree this light will reflect. Now I have to draw a ray in such a way that this has to be 60, this is 30, this is 30 and 30, so this has to be something but not 90. So what can you see here? You can see that this goes like this, and then this ray emerges away from normal, right? So without calculation, but what calculation? That sine I upon sine R is equal to 1.5. Without using this calculation, you can still draw these rays. Try to give all your rays arrows so it is clearly visible. Also try to draw all the normals that you use. Then we have a student. Two students are measuring speed of sound. Students are provided with a starting pistol, a stopwatch and a long measuring tape. The starting pistol, when fired, produces a loud sound and puff of smoke at the same time. Describe how the students use apparatus and show how they calculate speed. You may draw a diagram. See, I'll draw one student who has a pistol in his hand. Other student, right? Their distance is 200 meter. I want to look at this distance as 200 meter. Because there is a long measuring tape, I can find out the distance between them. This person has a stopwatch with him or her, right? What you will do? Two students stand 200 meter apart, one with stopwatch, other with pistol. Student with pistol will fire and the student with fire it, let's write it like that, and the student with stopwatch starts it when he sees smoke and stops it when he hears the sound, right? Because it is a very loud sound, it will be heard. Then use formula V is equal to 200 upon T. Right, we have taken distance as 200, where, explain your formula. 200 is distance, V is velocity, and T is time on stopwatch. Right, so what they have done, as soon as this bullet is fired, or as soon as this gun is fired, there is a smoke, and on top of that there is a loud sound. Smoke can be seen immediately because light travels faster than sound, but the sound will take some time to reach here. We have taken a considerable large distance so that the person is able to differentiate, or at least have some time to start and stop the stopwatch. You can also use 300 meter, 350 meter, all of them will be correct. Cannot use a very long distance, because at very long distance the visibility gets blurry, right? You cannot see 1 kilometer apart without binoculars, so binoculars are not given. You cannot use a very large distance. Then, a device that is at the bottom of the sea emits a sound wave of frequency 200 Hz. The speed of sound in seawater is 1500. Calculate the wavelength. V is equal to F lambda. Right? Lambda is equal to V by F. So, always make sure that on left hand side you write the equations. You make the subject of formula whatever you are finding out, and only after that you substitute everything else. So, you have 1500 divide by 200 is equal to lambda. You find out that it is 7.5 meter. Sound wave passes from seawater into the air. State what happens, if anything, to the frequency. Remains same. And what happens to the speed? As we know that when sound goes into air, its speed decreases. So, as it is a rarer medium, so it decreases. And they have already only stated or only asked what happens. Don't have to explain any of that. A ray of light passing through a length of curved optical fiber. Draw a diagram showing the fiber in the path of ray of light. See, this can be a confusion for a lot of you. So this is your optical fiber, inside which the light travels like this. It gets total internal reflection always. You can draw normals over here to show that it is total internal reflection. Describe one use of optical fiber in medicine. You may draw a diagram. So I choose not to. You can look at your textbook and find out these answers. To detect insides of a person's elementary canal, the light TIR and the light total internal, the light, let's write experiences TIR and travels from insides to outside, making the insides or inner organs visible. That is your answer. Then draw a straight line from each wave on the left to the most appropriate speed. So you have light in air. The speed of light in air is 3 into 10 to the power 8 meters per second. Microwave in vacuum, we know that microwave is also an electromagnetic wave, travels at the speed of light. Then we have sound in steel. The speed of sound in steel is 6000 meters per second. In water it is 1500. In air it is 340. Refractive index of a glass block is 1.5. Use your value for the speed of light to calculate the speed of light in this glass block. So you can write n is equal to c by v. We have done a very similar question over here, 3.0. into 10 to the power 8, the value that I have used, divided by, I don't know what is the value of V, but it is given that the value of refractive index is 1.5. So V is equal to 3.0 into 10 to the power 8 upon 1.5, which will give me 2.0, right? Because the question has stated significant figures, I will write 2.0 and then I will add units meters per second. Figure 6.1 shows a protractor superimposed on the path of ray of light. Light is traveling in glass towards the boundary with air. Use protractor to measure the angle of incidence of the ray at the boundary with air. So this is where your normal will be, and it is at 125. So this is your angle of incidence. So I have 125 minus 90, which should be 35. Just a second. Yes, it is 35 in calculator also. The refractive index of glass is 1.56. Calculate the angle of refraction. Sin I upon sin R is equal to n. Use the left hand side of the space to make the correct thing the subject of formula. So angle of refraction sin R by sin I is equal to 1 by n. R is equal to sin I upon n into sine inverse, right? And also show that you substituted the correct value. So sine 35 upon 1.56. So I have sine inverse of sine 35 divided by 1.5. Sine inverse of sine 35 upon 1.56. Oh, I am getting a syntax error. Is there a mistake I have made? I don't think so. Is the calculator, also check if your calculator is in degrees, sometimes it might be in radian. First let's find sine 35, divide this by 1.56, you get a very small number, and then sine inverse of this answer gives you 21.57. So 21.6, you can't say 21.6 because you don't have that many division. 21.5 degree it is. State what is meant by critical angle. We have already discussed critical angle. Please copy this answer down here. Even if it is asked more than one times, I would like you to answer this. The simple reason being that it has been asked repeatedly and I want you to remember this definition. Calculate the critical angle of the light in glass of refractive index 1.5 C. So now from the above, I'll write it one more time. You have n is equal to 1 by sine C. So sine C is equal to 1 by n, and therefore C is equal to sine inverse of 1 by n. So let's find out sine inverse of 1 divided by 1.56. It's 39.86. I'll write 40 degree. Write it 39.86, which is almost equal to 40, the nearest whole number. Then figure 6.2 show a water wave crossing a boundary from shallow water to deep water. Okay, name the process that takes place at the boundary between shallow water and the deep water. Refraction is taking place, right? The changing of path, bending. Tick one box corresponding to the property of the wave that is same in the shallow water as deep water. Frequency does not change. One, okay, we have no idea about amplitude, but speed and wavelength definitely do change. Describe use of X-ray in security implication. Include a diagram. So let's draw a small suitcase inside which there can be a lot of things. Let's say that this is a band, or let's draw small boxes, right? And X-rays can be used to look inside bags at airport without opening them to screen of potential threats. Okay, then we have radio wave, sound wave, and ultrasound and visible are all waves. State what is meant by ultrasound. Suggest a value for the minimum possible frequency of ultrasound. Sound waves with frequency greater than 20,000 hertz. You can also write 20 kilohertz, that is also correct, is known as ultrasound. State which of these waves are electromagnetic. So radio waves are electromagnetic, visible light is electromagnetic and longitudinal. Ultrasound, because it is sound, it has to be longitudinal. Do not confuse ultrasound with ultraviolet rays, they are different. Then this seems like a big question. Ultrasound passes through both human flesh and bone. Figure 5.1 shows an ultrasound source sending an ultrasound wave into human flesh. The ultrasound wave travels through the flesh to point X and then through the thickness of the bone at point Y. At Y, the same ultrasound is reflected and returns to X. The total time for the ultrasound to travel in the bone from X to Y and back to X is 9 into 10 to the power minus 6 seconds. So 9 into 10 to the power minus 6 seconds, which can also be written as microseconds. Calculate thickness T of the bone if the speed of ultrasound in bone is 4100 meters per second. I will use, because there is reflection, right, reflection of sound, I will use V is equal to 2D by T, right? We want to find out the thickness, so D is equal to VT by 2. So V is 4100, T is 9.0 into 10 to the power minus 6 upon 2, right? So let's find out 4100 multiplied by 9 multiplied by 10 to the power minus 6 and the whole thing divided by 2 in your calculator will give you 0.01845 meter. This will be your answer. Block is made from particular type of glass. Figure 6.1 shows light passing from air into the glass block. Using figure information from 6.1, calculate the refractive index of light in this type of glass. So first of all, don't make the mistake of considering 29 as the angle of incidence. Actually 29 is the other angle. Your angle of incidence is 90 minus 29, which comes out to be 61, and refractive index is sine 61 upon sine 33. So sine answer divided by sine 33 gives you 1.60. So I'll write 1.6 is the refractive index. It does not have any unit. Critical angle for light traveling in this type of glass block. So now I can clearly write sine inverse of 1 by n is equal to C. So sine inverse of 1 by 1.6. So I'll first find sine inverse of 1 by 1.6. It is 38.6, so 39 degree, right? Try to give this 38.68. So I will write 39 degree. State one application of optical fiber. Draw a diagram to show how optical fiber is used in this application. So you draw this diagram and then you show total internal reflection. See, even if it goes through this end, it is total internal reflection. right? You can show this also and then copy paste the same thing we have done in previous question. Then state a typical value for speed of sound in air, 340 meters per second. If you write 330, it's okay. If you write 335, it's okay. State the range of frequency that can be heard by human healthy ear, 20 hertz to 20,000 hertz. A sound wave in air has a wavelength of 22 millimeter. Figure 6.1 represents wavefronts of this sound. These wavefronts are successive compressions. Using your value for the speed of sound in A1, calculate the frequency of the sound wave. So you have V is equal to F lambda, and lambda is equal to 22 into 10 to the power minus 3 meter. So now what will I write? I will write V, which is 340 divided by 22 into 10 to the power minus 3 is equal to F. If I put that in my calculator, divided by 22 into 10 to the power minus 3, what I get is 15,454, right? So 15,454 hertz, or a better way of writing this is 15 kilohertz. Looks clean, has proper number of significant figures, and you've rounded it off correctly. On figure 6.1, draw dotted lines to represent 3 different refractions. So what you will do, because this is 11, right, and they have told you rare fractions, how do you show them? Now this line is a crest, this line is a crest, right? Or these two lines are compression, exactly between them there is rare fraction. So 1, 2 and 3. You could have drawn it over here, you could have drawn it over here. I would not recommend over here because this is not exactly between the lines and therefore can be discarded. State in terms of both molecules and pressure what is meant by rarefaction. The concentration or the pressure on molecules at these regions is the highest. Then figure 7 shows a box ABCD. Box contains 2 identical glass prisms, one of which is shown. Light incident on prism 1 undergoes total internal reflection within the glass. On figure 7.1, complete the path of the ray through prism 1. On figure 7.1, draw a second prism inside the dashed line, positioning it so that the light reflects inside the glass and emerges from the box as shown. Then complete the path of the ray. So first let's do this. Here I will just draw a line like this. Now here what has happened, guys, they have not stated, but in your textbook you will find that this is nothing but a prism which has these angles as 45. Now in the previous question the angle that I just marked was not 45 and therefore the ray was bending, but here because the angle is 45 the ray would bend like this and then get reflected from here somehow and go like this. How can you achieve this? You can achieve this if the slant surface does appear like this, which will make the ray total internal reflect again, right? And this is how the prism can be placed. So this is what the prism looks like, right? And this is the direction of the ray that looks like this. Then I have done both part AI and II. State the statement that correctly describes the necessary condition for light to undergo total internal reflection. Tick 2 boxes. The light is incident on the glass is less than the critical angle. The light incident in the glass is greater than the critical angle of light in the glass. Okay. The angle of reflection in the glass is equal to angle of refraction. No, it's not. The speed of light in the glass is greater than speed of light in air. It's not. The speed of light in glass is equal to speed of light in air. It's not. The speed of light in glass is less than the speed of light in air. The pitch of the sound increases. Tick one box to indicate the change that occurs when pitch increases, frequency also increases. Loudness of the sound wave increases, therefore amplitude also increases. Then we have on figure 6.1 shows astronaut and spacecraft on the surface of moon where there is no atmosphere. Piece of machinery within the spacecraft produces a loud sound of frequency 12 kilowatts. Tick one box that indicates the reason why the astronaut cannot hear the sound, because the sound only travels with the help of material medium. As there is no atmosphere, he will not be able to hear this. Material of the safe is not soundproof, cannot travel through vacuum. Right? Some training for space travel is carried underwater. State an approximate value for the speed of sound in water, 1500 meters per second. Calculate the wavelength in water of sound wave of frequency 12 kilohertz. So, lambda is equal to V by F, and V 1500, F 12 kilohertz. This will be the value of lambda. Quickly adding that in my calculator, I find that it is 0.125 meter. Figure 6.2 shows successive crests of a water wave approaching a narrow gap in a barrier. Okay, on figure 6.2, draw three crests of the wave that have just passed through the gap in the barrier. Now what you should look for is the gap having a similar length as wavelength. It is. So what will happen? You will see concentric circle, right? What you have to do, you have to try and keep this gap as it is and draw at least three concentric circle. If you have a rounder, use that in this question and you can easily find your answer. Then we have question number 12. Student draws a diagram to represent the electromagnetic spectrum. Figure 8.1 is the student's diagram. Okay, this is increasing wavelength. The student has made two mistakes. Cross out what is wrong and correct in the diagram. Okay, earthquake waves are not electromagnetic waves, right? Ultrasound, X-ray, gamma. Okay, and what is the other mistake? Infrared radiation, ultrasound, visible. The only thing that I can think of is this should be increasing frequency, but I will have a look in the textbook. Or is it some order? Visible is okay. Vibcure, right? R, the one with highest wavelength. So okay, this is right, this is right, this is right, this is right. I think X-rays, gamma rays, only then this is the change. Okay, look at the textbook, you tell me what are the two mistakes. Speed of light in an optical fiber is given. The speed of light in vacuum 3.0 into 10 to the power 8 meters per second. For light in the material from which optical fiber is made, calculate the refractive index. N is equal to C by V, which is equal to 3.0 into 10 to the power 8 upon 2.0 into 10 to the power 8. This will give you 1.5. Then critical angle sine inverse of 1 upon 1.5. I know that this is 41.8 or rather 42 degrees. I'll just write it here. You need to show method. Figure 8.2 shows a section of optical fiber. Light is traveling in the optical fiber. State the full name of the process taking place in the as light crosses. Light changes direction. Total internal reflection. Right? This should have been your answer. Question number 13. Figure 6.1 shows the crests of a wave in the sea as it reaches the entrance to a harbor. Wave reaches the gap in the harbor wall and passes into the harbor. Draw the first three crests on the right of the harbor wall. So what you will do, you will look at what is this gap. and how much is this gap. Now clearly the gap in the wall is greater than the wavelength, right? So diffraction will not take place. So you will draw three vertical lines because diffraction is not taking place, just a little bit of bending, no spreading is taking place. Also you would have scale, so you will be able to draw a better diagram. Just make sure that these distances between the two waves and these distances between the two waves are equal. Then a wave with larger wavelength, now if you see this and this gap are almost equal, approaches the harbor. Figure 6.2 shows this wave. This second wave reaches the gap in the harbor wall and passes into the harbor. On figure 6.2, draw the first three crests on the right of the harbor wall. So what you will do, you will draw semicircular waves. So 1, let's say 2, and let's say 3, right? You have to take care that this distance and this distance is equal. You'll have a rounder to help you with, so you can draw better diagram. An earthquake produces two types of waves, P waves and S waves. The vibration in P waves are parallel to the direction of travel. The vibration in S wave are perpendicular to the direction of travel of wave. Place one tick on each type of wave to indicate is it longitudinal or transverse. So electromagnetic is transverse. P wave, it's parallel. Parallel is longitudinal. S wave, it is perpendicular. So transverse. Sound wave is longitudinal. Ultrasound is also longitudinal. Ultraviolet is transverse. Some of the components of the electromagnetic spectrum in order of decreasing wavelength are shown. Sound waves, radio waves, microwaves, visible light, ultraviolet radiation, and gamma rays. State the speed at which electromagnetic waves travel in vacuum with the value, don't forget to add units. State which of the components of the electromagnetic spectrum has shown the lowest frequency. So if you remember your EM spectrum, you can just easily fill that out. I think should be gamma rays, right? Then you have two components of the electromagnetic spectrum are not listed above. State their names. So infrared is not listed and X-rays is not listed. Then one application of microwave is microwave ovens. Blah, 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 blah. The question is state one reason on application of microwave. One application of microwave is in microwave ovens which cook food very quickly. Figure 7.1 shows the inside of the glass door of a microwave oven covered with metal mesh. Metal mesh prevents the microwave from escaping by reflecting them back into the oven. State one reason why is it sensible to prevent microwave from escaping. To prevent energy loss. Okay, that is one. State one further application other than microwave ovens. Communication. Right. So these are the two reasons or answers. For blue light, refractive index for a particular type of transparent plastic is 1.5. What is the critical angle for blue light in this type of plastic? So directly sine inverse of 1 upon 1.5 will give you 41.8. Should write it as 42 degree. Then a block is made up of this type of plastic. Okay, blue light traveling in vacuum is incident on the side of the block point P. Shows the angle of incidence is 45. At P, some of the light is refracted into the block and some of the light is reflected. The blue light used in the experiment is monochromatic. State in terms of measurable quantity what is meant by monochromatic. Single frequency, right? Monochromatic light means light of single frequency. Calculate the angle of refraction of the light in the glass block. So what you do, you simply write it like this. You have sine I upon sine R is equal to 1.5, and as you are using blue light, you can keep using this formula. So keeping the values, you have sine 45 upon 1.5 sine inverse of this whole thing is equal to r, right? You can write down that answer and add degree to it. On figure 8.1, draw the path taken by the light that passes into the block and the path of the light reflected at P. Okay, so there are two light rays they are asking you to draw. They are asking you to draw a refracted one and a reflected one. So you already found out the angle of refraction. Let's say for me the angle of refraction is 38. What will happen? I will draw an angle of 38 over here and show a line like this, and I will show another line with an angle of 45 over here and say that it is reflected. They are asking reflected and refracted both. On figure 6, question 16, on figure 1.7, object is blah, blah, blah. Okay, one tick on all the boxes correctly is yes, it is diminished, meaning it is smaller. So if it is diminished, cannot be enlarged. Is it inverted? Yes, it's not upright, it's facing upside, is facing down. Then real, because the rays are actually meeting, it is real. On figure 7.1, draw a ray passing through the principal focus of the lens from the tip of the object to the tip of the image. Label the principal focus. So what you will do, first you draw a line parallel to the principal axis like this, right? And then meet the object tip and this like this. So this becomes your principal focus F. Use the ray you have drawn to determine the length of principal focus. Because I cannot place a scale over here, I have options of zooming in and out. So I think it should be around some 2 centimeter. You can measure it in your diagram and find out. Draw another ray not passing through principal focus of the lens, passing from tip of the object to the tip of the image. So this is the third image that we have talked about. It will go parallel and then passes through principal focus. They have said not passing through principal focus but still joining. So you can then passes from. Okay, so if you don't want it to pass like this, you can draw a ray which is non-parallel, bending and then reaching like this. Then this point where it is crossing over the principal axis is not principal focus, right? Ray of light in glass is incident to the boundary, on a boundary with air. State what happens to the ray when the angle of incidence of the ray is less than the critical angle of the glass. It emerges out, right? And then greater than the critical angle of glass, it gets reflected inside. Okay, so here they have said 6.1 shows a ray of light incident on glass block at a critical angle of the glass is 41. Okay, so this angle is but obviously 60 and therefore there will be total internal reflection. This will also be 60 and it will bend. This will also be 60 and this will bend like this, right? So this is your answer. Calculate the refractive index of the glass. You can simply write n is equal to 1 by sine C, because incidence and refracted are not given here, but definitely the critical angle is given. So you can find out the answer for this, right? Should be somewhere 1.44. A loudspeaker produces a sound of constant frequency. State what is meant by frequency. Number of vibrations per unit time or per second, you know, that is frequency. Then we have the second way, what is meant by compression. So I have skipped reading the question. What is meant by compression? Region of high pressure. You can also write high concentration of particles. A lot of particles are in that region, right? Then the width of the gap is smaller than the wavelength lambda of the wave. On figure 7.1, draw the pattern of the compression after the sound wave has passed through the wave. So they have already said the gap is smaller, right? So what will happen? spreading, right? What do? You keep this and this distance equal, right? Use rounder and make that equal. Barrier is adjusted so that the gap becomes wider. Describe how this affects the pattern of compression after the sound wave has passed through the gap. The spreading of the compression decreases, right now as it is going in this beacon form, it stops doing that. The frequency of sound wave is 6800 hertz. The speed of sound in air is 340. Calculate the wavelength. So 340 divided by 6800 should immediately give your answer. So this is 1 by 20, which can be written as 0.05 meter. Typical value for the speed of sound in liquids 1500 meters per second. Then on figure 6.1 represents a wave on a rope. Find the amplitude of the wave. So to find the amplitude, first find the mean position. This goes from 0 and goes to this point. Let's find out how much it is. 1, 2, 3, 4, 5, 5th, 6th and 7th division it is, right? And each should be 7 into 0.2, so 1.4. so 6 plus 1.4 is 7.4. if you already can find it out like this, that this is 7, 7.2 and 7.4, then also it's okay. This is the logic. So it goes till 7.4. the mean position is 4, so answer is 3.4 meter. Or is it centimeter? It is centimeter, so I should write centimeter. Wavelength of the wavelength of the wave. So till here, let's find out how much it is. It is 30 centimeter, right? So 30 centimeter. You can also find out the total distance is 120, and there are 1, 2, 3 and 4 waves. So 120 divided by 4 will also give you 30. Both the methods are okay. Then you have a wave traveling on the surface of water has a wavelength of 2.5 centimeter and a speed of 8 centimeter per second. Calculate the frequency of the wave. So you have V is equal to F lambda, right? This is centimeter per second, so no need to convert. So we have F is equal to 8.0 upon 2.5, and copy down your answer here. Write hertz as the unit. Do not forget to write units. Then let's skip all the text and read this. On figure 6.2, draw a pattern formed by 3 crests after the wave passes through the gap in the barrier, right? I will draw this and then show a little bit of bending because the gap is much larger than the wavelength. Water is added to the tank and the speed of the wave in the deeper water is greater than the shallow water. The frequency of the wave remains constant, but its wavelength is different. State and explain how wavelength in the deeper water has changed. It is greater, right? And V is equal to F lambda. State and explain. Greater velocity, longer wavelength. That is your answer with explanation. Apart from the change in wavelength, describe one other difference in the pattern formed by the crests after the wave passes through the gap. Okay, so if the longer wavelength, then it spreads, appears diffracted, right? Because when wavelength increases, it might reach the gap in the barrier, and if that happens, then definitely diffraction will take place, right? These are the 30 pages that we were supposed to understand till today, right? Those of you have doubts, I will assign the rest of the worksheet in time. We can discuss those doubts in that time.